regression model. Create an instance of the model using the estimator shown here. Fit the training dataset into it. You can print the intercept and coefficient of the linear model using the built-in functions shown here. Now, it's time to predict the response using the test datasets. This is accomplished by using a predict object and passing the test data to it. You can see that it gives you the predicted values in an array. You can always verify them against the actual values to test if your model is accurate or not. A better way to test your model's accuracy is to calculate its mean square error. To do that, you must first import the NumPy library and the metrics class from Sklearn. Use NumPy's square method and pass the built-in mean square error function of metrics by applying them on the response test and predict objects. It will give you the mean square error present in the model, and you can use it to determine the accuracy of the model. Import the library for pandas. Also, import the given diabetes dataset and store it in a pandas data frame. Set the header to 0 as the dataset does not have a header. Use the head method to view the first 5 observations of the dataset. You can see here that the column headers are not descriptive, and without them you can't understand the data at all. So open the diabetes dataset with the .names extension with the Notepad++ application. You can see the name or description of all the 9 attributes. Use this to set the feature name shown here. Now you can rename the headers of the original dataset with the attribute names that you have selected. View the first 5 observations of the dataset once more. You can see that it now contains the appropriate feature names. The last column, called Label, contains binary values, where 1 indicates that the patient tested positive for diabetes, while 0 indicates a negative test. If you view the shape of the dataset, you will see that it has 700 observations and 9 features. Next, select a few features that you would need in the model. Use them to build the feature object. Use the label data values to build your target object. Use the shape method to verify the number of observations for the feature and target objects. You can see that both objects have 768 observations. You will have to use them to build the model. Next, import the train test split class. Use it to split the dataset into training and testing datasets with the help of the feature and target objects. By default, 75% of the dataset gets split into a training dataset, while the remaining 25% becomes the test dataset. Now, import the logistic regression model. Create a predictor object and fit the training datasets into it. You can now predict values for the testing dataset. This is accomplished by using a predict object and passing the test data to it using the predict method. You can always verify the predictions against the actual values to test its accuracy. You can also use Sklearn's built-in metrics class to test your model's accuracy much more efficiently. Use metrics accuracy score method and pass the response test and predict objects to it. It will give you the accuracy score of the model. The closer your score is to 1, the higher the accuracy of your model. Let's print the actual predicted values of the response using the syntax shown here. Let's now quickly recap what we have learned in the lesson. Sklearn has many built-in functions and algorithms which make it easy for data scientists to build machine learning models. Machine learning can easily and quickly extract information from large sources of data. Supervised and unsupervised machine learning models are two of the most widely used learning models. Supervised learning models are used to predict the outcome of a dataset. Unsupervised learning models are used to find the structure of a dataset. For continuous data, you can use regression algorithms if it is a supervised learning model. However, use dimensionality reduction for unsupervised learning. For categorical data, use classification algorithms if it is a supervised learning model and clustering if it is an unsupervised learning model.